Dear students, in the last class we have seen the capacitance of a spherical capacitor. Today, in this video class, we will see the capacitance of a parallel plate capacitor. We know well that what is capacitor. It is an electrical and electronic device which has two plates which used to store the charges. We know well that the parallel plate capacitor consists of two plates A and B. In this plate A, the insulated plate A positive charge plus Q is given to this plate. Now the voltage in this plate is V. Now the another insulated plate, capital B, is brought near to A. Already the plate B is a insulated plate. It has the atoms. The atoms consist of a positive charge and negative charge. So this plate consists of a bound plus and minus charges. When this insulated plate B is brought to near to the A negative charge is induced on the other plate B. So it is a plate A with plus Q positive charges. This plate is brought nearer to plate B. So already in the plate B, the charges plus minus are bounded together. When it brought near to this plate, the positive charges in the plate A attracts the negative charge and repels the positive charge. So the negative charges are appear in this surface and positive charges are appear here. Now the plate B is earth. So the positive charges on the other side of the plate B is earth. So this setup consists of plate A with positive charges plus and this plate with the negative charges minus. And here we have to derive the capacitance of a parallel plate capacitor. It consists of the two metal plates, each of area A. It is separated by a distance D. So the plate A and B is separated by a distance small d. The medium between these two plates is air medium. So the permittivity of the air medium is epsilon naught. So it is the ability to permit the charges. Now a plus Q charge is given to this plate A. You know that when this plate is brought near, so it induces the negative charge minus Q on the upper surface of the earthed plate. This is the earthed plate B. So it is the plate A consists of charges, positive charges, this is a plus Q, separated by a distance D. This is the plate B. This positive charge induces the negative charges here in this surface. The back side of this plate B is earth. The lines of force starting from the plate A and ending at the plate B, which is a perpendicular to this plate. The lines of force are perpendicular to each plate. Here a sigma. What is sigma? Sigma is the charge density. It is a charge density. The charge density, the density of the charges, the amount of charges, it is a charge density. So sigma is equal to charge divided by area, the number of charges accumulated in the particular area. It is known as charge density. Sigma is equal to Q by A. Now, by the application of Gauss law, the electric field is the electric field at a point between the two plates. The point is here, it is the electric field here, it is the point. This point, the distance between the point from the plate A is R. So the point is taken in the air medium between the plate A and the plate B. So this point is taken here. At this point, the electric field is calculated. This electric field E at this point between these two plates is given by sigma by epsilon naught. What is sigma? It is a charge density, the amount of charges in particular area. You know well that the epsilon naught is the permittivity of the medium, air or any material present in the gap between the plate A and plate B. So the potential difference between the plate A and B is given the potential difference, that is a voltage. Potential difference is nothing but a voltage. So this V is equal to minus integral small d to 0 E into dr. Now substitute the value of E, the electric field, sigma by epsilon naught, and then integrate this. On integrating, the sigma and epsilon naught is here constant. So distance, the variable quantity is the distance. So on integrating the dr, we get R. On substituting the upper limit 0 and then the lower limit d, you get minus d, and then the potential difference between the plate A and B is given by sigma d divided by epsilon naught. We know well that the capacitance of a parallel capacitor, already we have defined, the capacitance of the parallel plate capacitor is given by the capacitance is equal to charge by voltage created between plate A and B. So on substituting the value of the charge Q is sigma A and voltage is sigma D by epsilon naught. On simplifying, we get C is equal to area A, the permittivity of the free space, that is the air, and the distance between the two plates. So the capacitance of the parallel plate capacitor C is equal to A epsilon naught divided by D. So the capacitance is directly proportional to, that is, it depends upon the area of the plates and the permittivity of the air, the space, the material present between the plate A and B, and also it is inversely proportional to the distance between the plates. If the distance between the two plates increases, the capacitance decreases. When the capacitance of the parallel capacitor increases, when the surface area increases and the permittivity increases. The capacitance decreases when the distance between the two plates increases. So it is the capacitance of a parallel plate capacitor. Okay.